Yeah, we are ready to go now. See, as I told you, we are going to start with the HAP thermal load calculation. Okay, so here thermal load calculation, basically we will be discussing about the purpose of cooling load calculations, external load, internal loads, sensible and latent heats, U factor, R value, the envelope load, occupancy load, lighting load, then there is a equipment load, infiltration, ventilation load, bypass factor, thermal load calculation. So these are a lot of calculations basically, right? Thermal load calculations.
Yes.
Okay, but before we go directly to the thermal load calculation, I request you to go through the basics. Okay, the HVAC basics. Say for example, if you talk about local codes. Okay, you are in KSA and we are in UAE. Okay, so every local condition we have a different ambient conditions, right? You have a different ambient condition. I have a different ambient conditions. Okay, so that understanding is really required to get some idea about ambient conditions. Okay, let me open one of the video, one of the website where you will understand the ASHRAE guideline. Okay, so this is the ASHRAE climatic conditions. You can watch, you can able to see, right?
Yeah, I can see. Yes.
So this is the very basics. Okay, whenever you start with air conditioning project, the location is very important. Okay, say for example you are working for India projects, or you are working for Saudi projects, or say for example European project. Whatever the projects, the first understanding is the local condition, as a climatic design condition. Okay, say for example if you go to station, if you go to Asia. Okay, so here you will get access for all entire global. Okay, you can go to Asia, North America, Latin America, Australia, Europe, Africa, Antarctica. Okay, whenever you work for the, say for example, many consultants working for a global projects. Okay, not only maybe they sit in Dubai, or they may sit in KSA or in India, but they work for local global projects. Okay, so when they work in global projects, say for example, if you go to Asia, okay, here we go to, say for example, Saudi Arabia, right? And say for example, I will talk about Jeddah, for example. Okay, so if you click Jeddah, you will get all the ASHRAE conditions. Okay, so here you can talk about, say for example, extreme annual design condition. Okay, so here you will talk about 45.6 degrees Celsius and 31.3 degrees Celsius, right? Wet bulb and dry bulb and wet bulb.
So that's the mean temperature, right? That is the average.
This is the extreme annual temperature. Okay. Okay. So you can talk about the maximum and minimum.
Okay.
Sometime you may experience with the negative temperature, right?
Yeah.
Okay. So say for example, why the maximum temperature and minimum temperature is very much required. Say for example, you have air conditioning machine which will work for the entire whole year, right? Starting from January to December. So whenever you design the air conditioning, you should consider the minimum temperature and maximum temperature as well. Okay, so we will discuss more in coming classes. Okay, so this is the ASHRAE climatic condition. Okay, so here we will talk about what is the coldest month and what is the hottest month, right?
Okay.
Okay, so here if you see 1, it is nothing but January. Okay, when you talk about 12, it is nothing but December. And when you talk about 8, it is nothing but August, right?
Okay.
So in Jeddah, you have a hottest month will be the August month, and the coldest month will be the January month, right?
January month. Okay. That's why they mention 1 and 8, right?
Yeah, that is why they mention 1 and 8. Okay, clear, right?
Okay.
And also, I sent you the video to understand what is dry bulb temperature and what is wet bulb temperature, right?
Yeah, that I saw it.
Yeah, so that you will have a basic idea what do you mean by dry bulb temperature and what do you mean by wet bulb temperature. Okay, so if you have these two, you can also calculate what is the relative humidity, right?
Yes.
And also you can calculate what is the specific volume, and you can also calculate what is the dew point temperature, what is the specific humidity or humidity ratio, correct?
Yeah.
So if you know this two value, you can go to the psychometric chart and you can able to.
But just one more thing.
Yeah.
For the designing this one, this is the extreme condition, right? But we will not consider the extreme condition for the design consideration. So usually, which one is we will consider here?
No, for the design, you will consider extreme condition only. See, for example, your air conditioning is working for the whole year, right?
Yeah.
So assume that your say for example during the August month, okay, during the August month, your air conditioning may the temperature in your local condition may go to 45.6 degrees Celsius. Okay, so if you don't design for maximum temperature, your air conditioning you will not get the proper cooling, right? right?
So what about this one? N-year returns period values of extreme conditions. So we will not go
Uh,
with that average.
yeah, see, actually, this is based on the client requirement. Say, for example, if you talk
Mm,
about a critical mission, like say, for example, you have a data center or you have a
mm,
say, for example, hospital, okay, where
mm,
you cannot able to even say, for example, 1 hour failure or 2 hour failure for the whole year also it's
mm,
not accepted. Say, for example, if you are talk about Facebook, you are continuously we are working we are watching the Facebook, right, or YouTube. We are
mhm.
continuously watching the YouTube. So that means the shutdown is not at all accepted even for 1 minute or even for sometime it go even seconds as well, right? The
Uh-huh.
interruption is not accepted. Say for example, you have a server room for the aircraft for airlines. Say for example, right? It will work for every 24 hours, 24/7. So that means the your failure scenario is not at all accepted even for 1 minute or 1 second, right?
Yes.
So during that scenario, they will go with n equal 20 years. Okay, say for example, your outside temperature, say for example, as a extreme annual temperature is 45.6, but assume that in n equal to every 20 years, it may go to 49.6 hours
Mm,
degree Celsius, right? So that means you have to design for
yes.
49.6 degree Celsius, the maximum temperature. Okay, it
Okay.
depends upon the type of facility. Say for example, if you are working for residential project, okay, you don't need to go for n equal 20. You can just go for maximum temperature, right?
Hmm.
Okay,
Yes.
even some consultant will design for this temperature, dry bulb temperature and wet bulb temperature. Okay, zero point 0.4
That is that.
percentage.
That's what. That is the 1.1. What is that? That
Yeah,
is.
this is actually frequency. Frequency. Say for example, in assume that in every year, how many hours you have? 30 days into
24 hours.
24 hours. 30 days
24 hours.
into
Yes.
24 hours in a whole year. Okay, so total you can say that
Correct.
8760 hours, right?
Correct.
So in that
Okay.
8760 hours, the whole hour,
Mm,
the frequency, the 0.4 percentage may go up. Like say for example, 41 degree Celsius. The frequency
o-
41 degree Celsius
okay.
means that 0.4 percentage it may go up. Like above, you can say like 41 degree Celsius is the mean temperature. Like the frequency. Okay, during that year. Okay, and you
Okay.
may expect 1 percentage maybe lower down. Okay, and 2 percentage maybe 2 percentage of the whole year. I am talking about 8760 into 2 percentage.
Yeah. 2%. Okay.
Okay, so you say for example 8760 multiplied by, you can say 2 percentage. So you are expecting that 175.2 hours, it may be the range of 38.9.
38.9. Okay.
Yeah, this is the frequency of the whole year. Okay, but when we design the air conditioning system, we normally go with the extreme annual temperature, which is 40.6 and 31.3 wet bulb temperature. Clear?
Okay.
Okay, when you
Okay.
are
What
going
is
with
the
the,
sorry, MCWB means what? That is the.
it is a mean coincident wet bulb temperature. Okay. See, to get all understanding, if I will be sharing this particular website. Okay, go to this
Okay.
particular
Okay.
standard and just click here
Mm,
as climatic conditions. You will get all the definitions
mm.
here.
Okay.
You will get all the definitions here. Just now we discussed about, remember, the frequency,
Mm,
cumulative frequency. Okay,
mm-hmm.
if you talk about the coldest month, remember we just now discussed the one is
Yeah.
nothing but January and 12 is nothing but December.
December. Yes.
Okay, and dry bulb temperature corresponding to 99.6 percentage or 99 percentage is the annual cumulative frequency of occurrence, cold condition. It's like possibilities. We are not talking about
Right.
sure. There is a possibilities. Okay, like 4%, 99.6%, it may happen. 99
Mm-hmm.
percentage, it may happen. The frequency occurrence, right?
Mm-hmm. Mm-hmm.
Okay, and if you go, this all definition is given here. What is annual heating and humidification, monthly design conditions? Okay, and you can also learn about wind speed. Okay, then precipitation is the rainfall. Okay, the mean daily temperature, and what is the uh, energy we are getting through the sun, solar radiation, right? So these are all given here. So if you
Mm.
try to read all this information, you will get a basic idea about understanding of ASHRAE weather properties.
Weather properties. Okay.
Okay, so here you can see dry bulb temperature corresponding to 0.4 to 5 percentage and 10 percentage cumulative frequency of occurrence of the indicated month. Okay, then you have a mean daily temperature range, right?
Okay. Okay.
Okay. So this understanding, if you go through this particular guideline, you will get a basic idea about the local conditions, right?
Okay.
So
Okay.
why we study this like local conditions? So for example, uh, if I go to Saudi Arabia and if I go to Jeddah, for example, right? So here,
Okay. Yeah.
based on the dry bulb temperature and based on the wet bulb temperature, you can able to understand the complete properties of the air.
Yeah.
Okay, what is the relative humidity? Okay, and you can also understand what is the wind speed here and what is the direction of the wind direction. Okay, the wind directions. Okay, and
Okay.
about the humidification, coldest month. Okay, what is the wet bulb temperature? What is the wind speed during the coldest month? Right, and what is the evaporation and what is the enthalpy, dehumidification? You will get all this all basically as psychometrics, right?
Okay.
Okay, so if you go to say for example psychometric chart. Okay, so this is like a psychometric chart. I hopefully you have gone through before, right? So if you go to
Mm.
psychometrics, say for example psychometrics, you can able to get all the definitions: dry bulb temperature, what is wet bulb temperature, and what is the dew point temperature, what is humidity, specific humidity, absolute humidity, relative humidity, specific enthalpy, specific volume, then psychometric ratio. Okay, so these all the values is required for us to do the calculations, basically, right? Clear, right? Hello?
Yeah.
Yeah. Okay. So now, yeah, now I will be sending you this particular guideline as well. And one more thing. Yeah, if you start slowly reading the documents and try to understand, then you can able to go in depth. Okay. So little bit depth is very much important so that you can able to do some calculations. Okay. Say for example, if
Okay.
I will open one of the regulations.
So just can you explain me on this ashtray,
Okay.
which code where to refer like for thermal concentration? Just as a brief on the ashtray standards, which are the need to refer
Yeah, okay. I will tell you. I will
conditions?
tell you. I will tell you that. You mean the basics, right? Basic.
Yeah.
Okay. See, if you go to Ashray Fundamental, okay, Ashray 2021. Okay, if you go to chapter 17,
Okay.
yeah, if you go to chapter 17, here it is given residential cooling and heating load calculations, right? Okay, so here you have all definitions. If you go further down, there is a calculation approach. Okay, yeah, you can able to see the total load,
Hello.
the equations, right? The total load is nothing but sensible load plus latent load.
Hello.
Okay, yeah, I can able to hear. Yes, you can hear.
Hello.
Yeah, can you hear me?